Hi. In my last video, I implemented a QOI decoder in RL Meta. That video got over an hour long. It was time-consuming to edit, and probably not many people watched it all the way through. I think I want to aim for making much shorter videos. And one way to make shorter videos is to cover smaller topics. So that's what I'm trying today. In the last video, I also noted that some semantic actions in the QOI decoder got rather difficult to read, mainly because the lack of support for operators in semantic actions. Just a brief look at semantic actions. In RL Meta, you write rules that consist of a pattern followed by a semantic action. The semantic action can use variables captured in the pattern and also perform some basic operations like creating lists and calling functions. RL Meta has quite extensive syntax support for writing patterns, but semantic actions are more limited. The semantic actions for pixel processing in particular have very little pattern matching going on and very much semantic actions going on. So one way to make them read better is to instead implement the semantic actions in Python. So that's what we're trying today, and we'll then evaluate the results. Okay, so here is the QOI implementation. So let's first have a look at a small example how to implement a semantic action in Python instead of in RL Meta. So let's have a look down here at this one, for example. So this is part of the semantic action for process pixel, which here calculates the position where to store this pixel in the running array. So this expression with mod and msum and mall, we can call that like a pixel hash function. So let's try to just move that part to Python just to see how this can be done. So let's copy this one so we have it. Instead of doing this calculation here in the semantic action, this would instead be written something like pixel hash for RGBA, and the pixel hash is all of that hash. So now we can see a bit more clearly that if we format it like this, that both of these two lines are setting this pixel in the running array. This for the last pixel, and this one for the hash. Let me just turn on syntax highlighting that I was playing with. So this becomes a little bit easier to read. Yeah, so if you try to run this, decode monument QOI, there should be an error saying that this pixel hash function cannot be found. There we go, pixel hash. So there is a way that you can pass runtime variables to the semantic actions and implement those variables in Python. So let me show you how we can do that. So I think we have a main py file. So let's first just implement the pixel hash function. RGBA, and we had, this was the implementation from the semantic action, and it can be written like this in Python. So we have something mod 64, that something is r times 3 plus g times 5 plus b times 7 plus a times 11. And pixel hash was very difficult to spell. So something like that. And now we have to make sure that this pixel hash function is actually available to the semantic actions in the grammar. And oops, I'm in the wrong file. I'm in the wrong main file. This is the main file where I want to be. Okay, so pixel hash in the QOI main file. So there is a way, or there will be a way, to pass runtime variables to the QOI class. And here we just say that pixel hash should refer to this function. This will not yet work because of a small limitation in RL meta that we'll fix. So the problem is that this compile chain function that we're calling does not yet accept the runtime parameter. So that will be in the support library, compile chain. So let's make sure that it can take a runtime hash as well, default it to the empty hash, and we pass it to the run function of each grammar. So all the grammars up here will receive these extra runtime variables. And for now we just have the pixel hash. So let's try to run it again. There we go, and let's verify that the image is okay. Looks okay, right. So let's look at what we've got now. So in process pixel, instead of computing the pixel hash in RL meta semantic actions, we moved it to pure Python instead, and now we can write this much more clearly because you can use operators here in Python. So this is one way you can do it. So my plan for the rest of this session is to do this transform for all of these. So process pixel diff is really not matching anything. It's just a helper to process pixel, sort of like functions that we call in semantic actions by calling run and then the name of it. So there is no pattern matching going on here. The pattern matching is only used to simulate a function call in semantic actions. So I will implement all of these in Python instead, and instead of calling run process pixel diff, we'll do something like only call process pixel diff like that instead, and this will be implemented in Python. So I think I will fast forward that. You can have a look at me typing really fast and probably doing lots of mistakes, and when I am done we can come back and talk about the implementation. Okay, so I think we have a working version now. At least the monument.png file looks okay. Let's pause here for a moment. The image looks okay, But look at that error. We're actually looking at an old image. It was not generated by the code you're seeing. I didn't catch this error until editing, but fortunately the solution was quite simple. I'll get to it later. So let's have a look at what it looks like now. So the semantic actions for the chunks are no longer calling this run method to simulate function calls in RL Meta. So instead they call these process pixel functions, which are now implemented in Python. We also need to pass this running array because these functions are stateless and they don't know anything about this running array, and it is needed for the pixel diff calculations. So perhaps this reads more cleanly now, and if we have a look at the main Python file, it now looks like this. So process pixel diff, luma diff, and process pixel. The problem was that I have forgotten to return the pixels from the process pixel diff and process luma diff functions. After I added return statements there, it all worked fine, and the monument.png file was generated properly. And we still have this pixel hash, although I changed the signature to take a pixel instead, and the pixel is just a list of RGBA values. But these calculations that are done to diffs to calculate on process pixels can now be expressed using pure Python, using operators and everything that make them read much better than when expressed in RL Meta. So perhaps readability improved. On the other hand, you can't really understand the QOI decoder by just reading the RL Meta code. So you have to figure out have to go read in another file, what does process pixel do? Okay, so process pixel is here in the main Py file, and it's the stuff in the running array, and then returns the pixel. Okay. So another thing to consider is performance. I think in the previous implementation, it took like 20 or 30 seconds to generate the PNG file. So let's have a look now. Okay, so now we're down to 17 seconds, and I think that is an improvement in performance. And the reason why this is faster is because simulating function calls in RL Meta is not really that fast. In order to simulate a function call, we have to create a stream and run a parser, or run a rule to process that stream. So we'll pack the arguments in a stream, and then the parsing rule unpacks those values. And all of that is run in the RL Meta virtual machine, which is much slower for these kinds of things than the Python virtual machine. On the other hand, these are pure Python functions, and they don't involve the RL Meta virtual machine at all, so they are much faster. On the other hand, again, I think RL Meta is all about expressiveness and writing clean code here, and having to resort to writing some parts in Python, I think doesn't read as well. Although performance gain is pretty nice, if I remember correctly, it was around 30 seconds, and then it's quite a significant improvement here. but it doesn't matter. It's faster, and I expected it to be faster as well. But the question is, can we make it this fast without implementing them in Python? So I think that's a much more interesting problem to look at. Another downside of writing these semantic actions in Python is that they are not as portable. When they were written in RL Meta, they could be ported to any language which RL Meta can use as a backend. So say, for example, there was an RL Meta version that compiled to JavaScript. This QOI decoder would have worked and could have been run in the browser. But had it been written like this instead, these functions would also have had to be ported to JavaScript. So there's that trade-off as well. But what about the readability? So let's see. Stash these changes and reload this one. So what about readability? Say that we can make this as fast as writing them in Python. I mean, this still doesn't read as well, I think. So one thing that we could experiment with is to kind of support operators here, but to make that easy, we could use a Lisp-like syntax. So this part right here could be written something like this instead. So mod something 64. Hey, programming idiot. One topic per video, okay? Yeah, right. But this one, it will be really quick, I promise. So we'll be back with another video next week. Bye. G times 5, and then B times B7, and A 11.